Yes. Hello. Very good morning. Today I'm going to discuss about the one of the important concept called Towards experiment. So it is called Towards experiment. The Towards experiment was established of the oil film in these bearings is definitely a hydrodynamic phenomena. Here there is an hydrodynamic concept. The Towers experiment is based on the hydrodynamic concept or phenomena. It all started during the period of a great expansion of the rail loads in 1880s. It were conducted on the railroads in 1880s. A committee of the Institute of Mechanical Engineers hired this tower to determine the best method of lubricate a railroad journal bearing. At the time, it is called a railroad journal bearing. Mr. Tower already had a brilliant record as a scientist and the investigator of highest order, so that this uh, selection for the committee was justified as later events were shown. He conducted some series of experiments to determine the pressure development in the fluid film or oil film. And after that, he shown his experiment as well as made conclusion, and also he wrote the all the experience what he had at the time of conducting the experiment. For this experiment, he considered some of the standards for means he conducted experiment according to the some standards, not simply conducted. Uh, the tower conducted experimental investigation on the friction of bearing, similar to the bearing which were used that time in the railway loads. It's a one standard. Then these were a partial journal bearing, not a full journal bearing, and these were at that time they are partial bearings with a specification of 4-inch dia, the bearing having 4-inch dia and 6-inch long, having the arc of contact approximately 137 degree. Whatever the arc of contact, here you can see this is the a bearing he consider for his experiment. Okay, here you can see this is what the a bearing. Okay, here the arc of contact, and this shaft is having an 4-inch dia, 4-inch dia and 6-inch long, a 4-inch dia. So this is what the shaft which is covered by a bearing, and this bearing is a 4-inch dia and the length is 6-inch. Okay, so 6-inch and 4-inch. Uh, and the contact, here the contact is 137 degree. A special testing machine were constructed to conduct these experiments. This is what the special testing machine. Okay, he considered for his conduction of series of experiment. In the first series of test, Tower tried to feed the bearing through the oil hole. Here he made a one oil hole. Okay, this is a oil hole. He made oil hole to introduce the lubricant between the bearing and the journal. Okay, the oil hole in the center of the bearing. The hole, that oil hole, led the oil to the groove in the middle of the bearing, the parallel to the axis of the journal, which is parallel to the axis of the journal, and exactly it is in the middle of the bearing. It was found that with this arrangement, the bearing would not run coolly. Means, based on this experiment, it is not run coolly. Means, it did not got the best result. Even the load with only a 100 Newton, very low load, even with a very low load, just a 100 Newton, okay, the arrangement using this was not given satisfactory results. This is what the first set of experiment. Okay, an arrangement using curved groove was also tried. Means he replaced this groove, straight groove, with a curved groove, and was also tried with a given satisfactory results. Again the same results, he did not get the satisfactory results. A two groove, again they made, instead of one groove they made a two a parallel grooves. Means he tried to increase the lubricants or lubrication process, just to avoid the friction between the journal and the bearing surface. The two groove parallel to the axis either side of the center, close to the edge of the bearing, but it improved when compared to the first two set of results. And the load were increased by 3800 Newton, from 1000 Newton to 3800 Newton, and of course it is also not a better result. In the next series of tests, the grooves and hole in the bearing were sealed. Just made a seal on the oil groove as well as the oil hole, and a pad containing in a tin box, a pad containing in a thin box full of oil. Means the box is full of oil, was placed under the journal. Exactly, this is what the, okay, a tin of box which contain a oil, completely filled by oil, it is just placed below the journal, so that the journal rubbed against the pad in the turning or rotating motion. In every rotating motion, the pad touches the oil, or journal touches the oil. The pad was supplied with the oil by capillary attraction. Means the oil is supplied with an action called capillary attraction. Through the capillary attraction, the oil was supplied to the bearing and journal surface from the oil in the box, and this arrangement didn't give satisfactory results. Of course it improves the performance, but also not gives the best or better results. After that, the tower made the bearing run immersed in the oil bath. Means entire setup, whatever he had, the entire testing setup were immersed in the oil bath, or immersed in the oil bath, and this method of lubrication gives a best and better satisfactory results. What he made, he just immersed entire testing setup into the oil bath. Okay, and he start run the bearing, and it gives the very best or satisfactory results when compared to all the previous a series of experiments. Okay, means the coefficient of frictions was surprisingly very low, and he made some of the conclusions. After this, he made some of the conclusions. By seeing that experiment, he made some conclusion that the friction force is nearly constant. Whatever the friction force is nearly constant. Journal bearing follows the law of liquid friction. The first conclusion is the friction force nearly constant under the different load with ordinary working limit. Whatever the load with the ordinary limits, working limit, it provides the friction force nearly constant. And the second conclusion, the friction is perfectly lubricated. Means now the friction is in perfectly lubricated journal bearing follows the law of liquid friction. And the third conclusion, the friction is nearly independent. Friction is totally independent of the unit pressure, whatever the pressure, but friction is independent and increase with the velocity of the journal. Means whatever, if the increase the velocity of the journal, it increase the pressure. That is what the hydrodynamic concept. And the last conclusion, the frictional resistance in the bearing decreases as the temperature of the bearing rises. Of course, the frictional resistance, whatever the frictional force, which is reduces with respect to the increase in the temperature. Means the viscosity is also reduces with increase in the temperature, as well as the friction is also decreases with increase in the temperature. So, in the middle of an experiment, another important discovery was made by accidentally. The tower made some of the important concept while conducting this experiment. Means whatever he made a hole in the first set of experiment, he made a hole just to introduce the oil film, just to introduce the lubricant between the bearing and the journal. Okay, so that oil hole, okay, that oil hole drilled through the cap and the center of the bearing in order to introduce a ordinary lubricant for the first or second set of series. Okay, then the machine was put in the oil bath. Immediately after starting, the oil the oil in the oil bath begins to flow through the hole. Means he made a oil hole, so through that oil hole, the whatever the fluid or lubricant in the oil bath will start coming out through the oil hole or drilled hole. The journal appears to be act as a pump, because the journal will carries the oil from the oil bath and it will discharge into the oil hole, just act like a pump. The pumping of oil from the oil reservoir out of the bearing. An attempt was made to plug the hole. Means the first he tried to plug this hole with the help of plugger, just to stop the oil flow from the reservoir to the outside. When the machine was started, again the plug was slowly forced out. Even though he plugged the oil hole with the help of plugger, but once the machine is started, yes, of course, slowly this plug was moving out. That is what with the oil pressure. Then he used, means because of this pressure, this plugger slowly moving out here, slowly moving out. Okay. And next, what he made is he very curious just to know how much pressure is generated inside the oil bath because of this machine or journal and bearing action. You just want to know the, or you just want to measure the pressure. Okay, because that pressure is capable to unplug the plugger, so you want to measure. So he just remove that plugger, and in the place of plugger he just installed the pressure gauge. Here you can see these are the pressure gauges. Okay, he just place the pressure gauge on the oil hole. Okay, uh, this and once you start, again of course, there is a dynamic action. It generates the pressure, and that pressure is well above the whatever the pressure gauge limit. Means the pressure gauge having a maximum limit. So it crossed the maximum limit of the pressure. Means the pressure is so high and which crossed the pressure gauge capacity. This experiment established the importance, a fact that in a journal bearing properly designed and properly lubricated by the fluid lubricant, the journal is supported by pressure development in the oil film so that there is no direct contact between the journal and bearing as well as it will sustain the whatever the load, external load applied on the bearing. Okay, so this is what important observation were made at the time of Towers in middle of the experiment. Okay, what he did entire this testing machine immersed in the oil bath and he starts the machine. So once he start the machine through the oil will start flow to the outside from the reservoir to outside. He just want to stop that so that he plugged the plugger in the oil valve. Okay, and again he start and because of the oil pressure it slowly unplugged and he were very curious to measure the pressure, so instead of plugger he placed the pressure gauge, and once he placed the pressure gauge and starts the machine and again it develops the pressure and that pressure limit is more than whatever the capacity of the pressure gauge, means it is very high pressure developed because of this action. Okay, and based on this he made some of the conclusions. The oil bath lubrication friction resistance follows the law of liquid friction compared to the solid friction. Okay, and that is what coulombs and adhesion. The fluid pressure is middle of the brush is more than the double of the mean pressure. Unstable friction resistance occurs during the lubrication other than oil bath lubrication properly due to the insufficient amount of the flow, and Tower's experimental results motivated researchers to understand the effect of various parameters responsible for generation of fluid film pressure. So based on his experiment and next so many research were taken place and made so many equations, derivations to know the friction, to know the viscosity and whatever the pressure development between the journal and the bearing surface. Okay, so here yes, this is what the notes I made on the Towers experiment. Okay, I written uh, some theory part. So if you go through this, you can better to understand what is the concept of the Towers experiment. Okay, in examination, it's a one important question. You may get in same kind of question with a neat sketch or explain Towers experiment for 6 to 8 marks. Was it clear? Hello. Towards experiment is one of the important question. Okay, I will share you the notes, this PDF. You just go through this. So with this, I will wind up this important and very interesting concept called Towards experiment. Okay, so these are the some specifications of the Towards testing machine. Okay, based on this, he conducted some series of experiments and finally got some conclusions and important contribution to the hydrodynamic bearing. So it is a cause for hydrodynamic bearing. It is based on the hydrodynamic lubrication.